Okay, today we're going to be working on polynomials and we're going to be working on their graphs specifically and how to write an equation from a given graph. So if you're up to date with the um, homework and the INBs, this would be putting together the last few lectures, the last two specifically, or really just Fridays. Anyways, what we've learned so far is about end behavior and multiplicity of zeros of the function. So we're going to start off with multiplicity and we're going to look at the x-intercepts. And I'm going to notice that I have three x-intercepts. I have one at -1, I have one at 1, 2, and I have one at 4. So I'm going to start in factored form. I know that x plus 1 would get me the 0, -1. X minus 2 would positive 2. And x minus 4. We would set these equal to 0 and solve them to get my x-intercepts. Now I'm going to talk about end behavior. This graph has an end behavior of as x goes to the left, y is going down, and at the right end it is also going down. And I know even functions, so that means the degree of the function, the highest power, that leading term has to be even. So this is going to have the highest power of like x to the fourth, x to the sixth. I also know it's opening down, so the leading coefficient is going to be negative. And I also know it has a y-intercept of -4. So I'm going to use all of this information to create the best equation for the polynomial. So the first thing I'm going to do is say, hey, this is an even polynomial. Right now, I just have three x-intercepts. So right now, I'm a cubic. So I've got to look at my function and say, okay, does it bounce anywhere or touch the x-axis anywhere? And that would be right here at -1. So I know that this factor has to occur an even amount of times. And so for right now, we're going to assume everything occurs even twice, odd once. And so now I have four factors. I have x plus 1, x plus 1, x minus 2, and x minus 4. So I know my parent function is an x to the fourth function. Parent function is just going to be the highest degree powered with nothing attached to it. So the most simplest would be an x to the fourth. Now what I want to do is just tune everything in. I know I have a y. I know that my leading term is negative. Right now, if I multiply all of my x's together, I get x to the fourth. Well, I know at minimum it's got to be a negative x to the fourth because it's opening down. So I'm going to put that right there. I said I also know by multiplying all my firsts together, I get my leading terms first term. I get that first leading term. So right now, with that negative added to it, I have negative x to the fourth. The last thing I need to check is that my y-intercept comes out correct. My y-intercept is if I multiply all of my constants together, whatever those multiply together, those are going to get me, I have some. If I multiplied all four of these terms out, that would take me a while. But I know, yes, there's this x to the fourth, and there might be a third term, and I mean a cubic term, a squared term, a linear term. I don't care about those. But then I'm going to eventually get a constant term, and it's going to be all of these numbers multiplied together. So I get of my constants. 1 times 1 is 1, times -2 is -2, times 4 is a +8. And it actually is going to be a -8 because I added that -1. So let me just change that right now to a -8. Okay. And however, my y-intercept is -4. So now I need some kind of a or multiplier out in front that would multiply to make that a -4. And I know that's got to be a half because if I multiply this whole thing by a half, now my 8 becomes a -4. So I know this front number should be negative 1/2. So my leading term is going to be a negative 1/2 x to the 4th. That is the hardest part of what we're really going to do. The rest is just going over characteristics that we've already have done before. For example, domain, this thing goes left forever and right forever, so it's negative infinity to infinity. The range, this thing goes down forever, and it comes up to this maximum point at the very top, which looks like 5, 6, 7, 8, 8.5-ish. You don't have to be exact a lot of times, just for me to know, like that seems reasonable to me, 8.5. If you wrote 8.4 or 8.6, you'd be totally fine. Okay, my relative max and mins, well, I just wrote a max right there at the top. And what does that look like? About 4.2, comma 8.5. Obviously, there'd be a little bit of room for error. 1, 2. Oh, that's 3.2. Sorry. Be careful there. And I'm okay just writing these points instead of function notation since there's going to be a couple of them. And my other max is that x-intercept at negative 1, 0. And my relative min, I've got one of those. It looks like about 0.8 down to what, negative 5, negative 6.2. You could have said negative 6.1. But it's a little bit further than negative 6, so don't just write negative 6. We can be better than that. Okay. By increasing and decreasing intervals from left to right, I am increasing here. I'm increasing here, so I only describe increasing and decreasing by my x values. Remember, the only thing that we're describing by y is range. So everything else is left to right. So my green over here is from negative infinity because from over here coming this way. So I'm increasing from negative infinity until where it stops on the x, which was negative 1. Be careful. I mean, look up at your relative amendments and max. Those are what splits up your increasing and decreasing. So you should be using a lot of those values from your relative min and max, those x values. And then I'm going to be increasing again from right here, beginning at, what did we call that? 0.8, all the way to the next max's x value, which was, what did we say, 3.2. Okay, and then decreasing would be the last intervals I have left over, which would be between this max of negative 1 and I have this one on the other side. So I have this first max started at negative 1, decreasing at negative 1 all the way to 0.8, and this one was at 3.2, and it's going to be decreasing forever. So as x increases, y's will be down there. Okay, my end behavior, that's pretty easy. They're both, my y values are going down. So as x goes to the left, my y is going down. Remember, this is the answer. This x going to positive or negative infinity just means the left side of your graph, the left end behavior and the right end behavior. So the answer is this part is what you're answering, the f of x. What is the y doing? Is it going up or down? And on the right side, I'm going down on both sides. Okay. What about my x-intercepts? Which one bounces? That would be negative 1, 0. Where do they cross? We decided that happened at 2, 0 and 4, 0. And my y-intercept was 0. Okay, my next graph is this W looking thing. And so I have two bounces, right? So I have one at x minus 1 times x minus 1 and x plus 1 times x plus 1. And it's going up and up. And my y-intercept is at 0, 1. If I multiply all my x's together, I get an x to the 4th. That matches up with the up and up. And if I multiply all my constant terms, -1 is 1 times 1 times 1, ended up getting 1. So it looks like my function should be x minus 1 squared times plus 1 squared, and my domain -infinity to infinity, and my range looks like it goes from 0 to infinity. Relative max, I got 1 right at the y-intercept, which is 0, 1, and I've got two mins, one at -1, 0, and 1, 0. I'm decreasing here, and I am increasing this little small spot and that. So if I'm going to do my increasing first, it looks like between -1 and 0. Be careful on that. That one's really tricky because when my x is 0, we really want to go to that y value. My next is the other interval of increasing is when x was 1 to infinity. Decreasing, I'm decreasing from -infinity, this first yellow line on the left, all the way down to the x value of -1, and then I'm decreasing from 0 to 1. Okay, my leading term is just going to be x to the 4th. My end behavior is up and up. So as x goes to -infinity and as x goes to infinity, remember -infinity just means the left arrow of the graph. And what is that left arrow of the graph doing? It's going up. X goes to positive infinity, that means the right arrow. And since this is even, it's going up also. I only have two x-intercepts and they're both bouncing, one at -1, 0 and one at 1, 0. There is no crossing. And there's my information. Don't forget to sign on to your Delta Math and work those problems. See you tomorrow.